Hello everyone, welcome to our presentation. Our paper topic is correcting the unobserved confounding bias by partial deep neural network and text embedding. Briefly speaking, this paper wants to solve the confounding issue in text analysis applications by using deep neural network and text embedding. First, let me introduce our research background. In the last decades, there's a surge of text analysis applications in the information systems discipline, such as consumer review analysis. For example, researchers may examine the impact of review sentiment on the review helpfulness. In this example, this relationship may be confounded by some text-related variables, such as review subjectivity and review readability. And typically, researchers will manually craft the text-related control variables. But the problem is that we cannot guarantee that all the important control variables have been included in the regression model. The potential best solutions should be deriving an algorithm to convert each document, such as a review, into a list of control variables without human judgment. In computer science discipline, there are two text representation techniques, including topic modeling and the neural network language model. Topic modeling mainly models the statistical relationship of word co-occurrence in the text. It will generate the probability distribution over topics for each document. And the neural network language model will learn the text embedding that can capture the semantic and grammatical relationships between words. It's more effective than topic modeling in many downstream natural language processing and machine learning tasks. Therefore, we will use text embedding outputted from the state-of-art neural language model, BERT model, as a text representation technique. The full name of BERT model is bidirectional encoder representations from transformers. This model can learn the language understanding model based on both left and the right context of the word. It has achieved excellent performance on 11 NLP tasks, such as general language understanding evaluation and question answering. After we define the text representation technique, the other problem is that typically the functional form of text embedding in a regression model is unknown. Therefore, the challenge is that how can we incorporate the embedding vector in the regression model so that we can retain both the interpretability of the coefficient of independent variable and the unknown functional form of text embedding. To solve this problem, we first set up our model. We propose a semi-parametric model, which is defined by equation 1 and equation 2. In equation 1, y is a dependent variable, such as a review helpfulness. X is an independent variable, such as a review sentiment. Z is a vector of the potential control variables, including the text embedding and other numerical control variables. G is a link function, including the identity function for OLS regression and the GLM link function. And the equation 1 is a main regression model, while equation 2 models the relationship between the independent variable and the control variables. GZ and MZ are unknown functions to be estimated by the deep learning model. They are used to capture the relationship between the control variables and the dependent variable, and the relationship between the control variables and the independent variable. After we define the model, we can design our model structure, which is partial deep neural network. The input of this neural network is document, which will be converted to text embedding by the BERT model. And the text embedding will be concatenated with other numerical control variables. Next, Next, this concatenated variable vector will be processed by two fully connected hidden layers. And the output will be a lower dimensional vector. This lower dimensional vector will be processed by three important layers next. First is control layer. This layer is used to capture the relationship between control variables and the independent variable, and the relationship between control variables and the dependent variable. Second is the partial OR layer, which is used to partial out the effect of control variables from the independent variable. By including this partial OR layer, the estimation of beta coefficient will be less sensitive to the prediction error of control layer. Finally is the outcome parameter layer, which is used to combine the control layer and partial OR layer to generate the predicted outcome. After we finish the training process, we can extract the beta coefficient from the neural network. This is the general network structure. Next, let me show you our simulation experiments for evaluating our method. We use Amazon review dataset in the experiment. The independent variable is review sentiment. Control variable is review subjectivity, which will be generated by Python package TextFlow. The correlation coefficient between review sentiment and the subjectivity is around 0.139. The true model is a linear or logic function of these two variables, which are defined by the following two equations. From these two equations, we can say that the theoretical beta coefficient of sentiment is 1. In this experiment, review subjectivity is an unobserved control variable, which will be captured by the text embedding. The outputted text embedding dimension from pre-trained BERT model is 768. The sample size of the reviews is 40,000. We will repeat the sampling 20 times and obtain 20 coefficients. We will report the mean of 20 coefficients. Next, let me show you our preliminary results. In this table, column 2 denotes the theoretical beta coefficient of review sentiment, which is 1. Column naive denotes the estimated coefficient only using review sentiment. So the results show that the naive method indeed underestimated the beta coefficient. And the column DML denotes the estimated coefficient by using the benchmark method, double machine learning. Due to the time limit, I do not introduce this method in detail. From the results, we can say double machine learning can only partially correct the estimation bias. Finally, column Partial-DNN denotes the estimated coefficient by using our method. The results show that our method indeed can correct the estimation bias fully. In summary, this study contributed to the literature in the following ways. First, we demonstrate the effectiveness of text embedding for unobserved variable controlling. Second, we propose a novel method, Partial-DNN, by utilizing the deep neural network. Our method can return both the interpretability of the beta coefficient and the unknown function form of text embedding. Finally, our method can be generalized to other forms of unstructured data, such as images and videos. That's the end of our presentation. Thank you.